Good morning, sir.
Morning. Wait for everyone.
Good morning, sir.
Morning,
Yes.
Ritika. Wait for 2 more minutes and then we'll start.
Okay, sir.
Did you all solve the questions?
Yes, sir.
Any doubts there?
No doubts.
Good. Ritika?
Sir, I also had no doubt in solving the questions, sir.
Okay. That's good. Has everyone arrived? Okay, we shall start now. Can we have the videos on? Yeah, that's good. What we did in the last class, fundamental derived quantities, then supplementary quantities. We defined those units also, no? Any doubt, anyone? Shall we start? Respond me. Otherwise, how will I know?
Yes, sir.
Okay. So we have seen different kinds of units and how they were made, right? Now we'll be seeing about the some practical units, some practical SI units that we'll be watching. What are some practical units? So basically, you must be knowing about these terms. 1 millimeter, then or I shall write about like this. kilo, then mega, giga, then deci, centi, milli, micro, nano, pico, and femto. These are some important abbreviations that we use generally. You must have seen them. So can you tell this what does this like corresponds to? For example, if I write kilo, what is the value it is corresponding?
Kilogram.
No, not kilogram. Kilogram. Gram, if you apply, gram is a unit. I can write kilometer on 10 to the power
10 to the
3. So wherever you write this, you have to apply 10 to the power 3. For example, if you say kilogram, so it is 10 to the power 3 grams, right? If you write kilometers, so if it is, then it is 10 to the power 3 meters. Similarly, mega is 10 to the power 6 and giga is 10 to the power 9. Understood? Right? Now, what is deci? Deci? In class 5 or 6, we used to learn about operations on large numbers or something like that, and then measurement of mass, capacity, and time. And I used to remember this table there: kilo, hecto, deca, meter, deci, centi, milli, like that. Do you remember, everyone? Okay, so deci is 10 to the power minus 1, centi 10 to the power minus 2, milli 10 to the power minus 3, micro 10 to the power minus 6, nano 10 to the power minus 9, pico 10 to the power minus 12, and femto 10 to the power minus 15 probably. Yeah. So these are the abbreviations we will be using basically, okay, during the course of study in class 11th and 12th. I'll give you some examples. So GB, that the internet data that you must be using. So GB is nothing but gigabytes, right? MB is megabyte. Then centi. Centi is 10 to the power minus 2. Milli 10 to the power minus 3. Micro units we use sometimes micro. Generally by like measuring the wavelengths and all frequencies, micros in there, that is there. Nano is also used in frequencies and radiations like that. Pico 10 to the power minus 12, again in those things only, because there that is the micro physics that we study. New physics has been added now in the syllabus, that is the what shall we say, that modern physics it is called. That in 12th we'll be studying about doping and what all are there? Dual nature atoms, nuclei, semiconductors basically, that were not added earlier. These are the recent advancements in physics. Okay, 1960s, 70s, like that. Then femto is 10 to the power minus 15, radius of nuclei of this order. Written, everyone?
Yes, sir.
Then we have angstrom. One more thing is there. Angstrom. That is 10 to the power minus 10. Okay. Micro is also called sometimes micron. Micron, mu, denoted by mu. Now some practical units. Okay. Some practical units. First one of it is light year. You know what is light year? It is distance traveled by light in 1 year. Can you imagine that? Distance traveled by light in 1 year. Okay, that is called light year. So you know speed of light is 3 into 10 to the power 8 meter per second. We are taking it approximately, otherwise it is 299792458. Okay, so if we take 3 into 10 to the power 8 meter per second, that is to be multiplied by time of 1 year. How many seconds are there in a year? So there are 365 days. Let us take 365.25 days to be exact. You know this, na? 365 and 1/4 days are there in 1 year. That's why the 1/4 gets multiplied every 4th year and we get a leap year there. 1 day added. Everyone knows this? Okay, so 365.25 days and each day has 24 hours, 60 minutes, 60 seconds. So this is the total number of seconds. Okay, so when you multiply this, you'll be getting the distance in meter, and that is 9.467 into 10 raised to the power 15 meters. Okay, so this much distance you get. So you'll be asking, sir, where is this used? Where we use the unit light year. So in measuring the heavenly bodies, the celestial bodies that are there, stars and moons and suns, there are different suns that are millions of light years away. You must have heard that term, black holes. So this is the distance. In any article, you must have studied about this. The nearest star to us is this much light year away, or that body or that new planet has been found that is this much light year away, like that. Okay. Now, second type of distance that we use. These are big distances. Astronomical unit. Astronomical unit. Okay. Astronomical unit. It is mean distance. Mean distance.
Of
Mean
sun from
distance.
Earth.
Pardon?
Of sun from Earth.
Yeah. Okay. And this is 1 AU is 1.496 into 10 raised to the power 11 meters. Third thing that we study is parsec. Parallactic second. What is this parallactic second? So
The
is
distance
defined.
traveled from sun to any astronomical unit.
Yeah, I'll explain it. I'll explain it. This has got some kind of explanation. It is defined as distance at which an arc of one astronomical unit subtends an angle of 1 second. Okay. Now see here. Let us say this is the sun. Okay. And this is the earth. This is the sun and this is the earth. Right? Now what we have to do, we have to choose a point where the distance between these two, this is the distance between these two, is 1 astronomical unit, and this angle subtended by it will be 1 second. Right? So this distance will be called 1 parsec. Now everybody tell me, how much time does it take for light to come from sun to earth? Who knows that? Nobody? It is around 8 minutes. It takes around 8 minutes. Like I don't know the exact value, but something around 8 minutes it is. So it takes 8 minutes to reach from sun to earth. The question will be asked you even in JEE mains. They can ask you like this: which one is the bigger unit or which one is the smaller unit? You have to arrange it ascending order or descending order. Even in JEE mains, they ask this question sometimes. And this is one of the easiest questions. People generally neglect this and 4 marks are gone. Sometimes they take their negative also. So how you have to remember this? First of all, light year is the distance traveled by light in 1 whole year. And astronomical unit is the mean distance from earth and sun. So light year is taking 8 minutes only to reach from earth to sun. Right? So it shows that this unit will be lesser than this unit, right? Understood, everyone? Because this here light is taking 1 year and here light is taking only 8 minutes. So this is smaller distance than this, first point. Second point, Parsec is the biggest distance, largest distance of all. Okay, 1 parsec, because it is 1 degree. So you see there, 1 degree angle we have to subtend how much? So not even 1 degree, 1 second. 1 degree, then 1 minute, then 1 second. Okay, the smallest unit of angle, 1 second. 1 second is that much small that you cannot measure it through the normal compass. Sorry, protector. So 1 parsec is 3.08 into 10 raised to the power 16 meters. That is 3.26 light years. Okay, 3.26 times 1 light year. So this is 1 parsec. Understood, everyone? Got it? So the order will be 1 parsec greater than 1 light year, greater than 1 astronomical unit. At home, you can try, you can find the ratio between light year and astronomical unit also. Okay. I guess, shall I tell you, or you'll doing it yourself? Shall I tell you that value, or you can do it yourself? Go on, speak something. Okay, I'll tell you. 1 light year is 6.3 into 10 raised to the power 4 times 1 astronomical unit. This is another relation. And now you can relate this and this to get the relation between parsec and astronomical unit, right? Written, everyone? Who will tell me how many light years are there in 1 meter? How many light years are there in 1 meter? Do it as fast as you can.
9.4.
How much?
Is it 9.46 into 10 power 15?
That is total distance in 1 light year. Now I'm asking you, how many light years are there in 1 meter? 1 light year was 9.46 into 10 raised to the power 15 meters. I want to ask, how many light year constitute for 1 meter? Light year is what? Unit of time or distance?
Sir, 1.07 into 10 power 16.
1.04
into 10 power minus 16.
minus 16, 16. That's correct. Actually, the answer is 1.05, but this is considerable. How you did? So see, this was unitary method, simple unitary method. If 1 light year is this much meter, I need 1 meter here. So 1 meter, what will I do? I'll divide this, take it to the other side and divide it by this right here, isn't it? Easy. You'll get this 1.057 into 10 raised to the power 16. Sorry, minus 16 light years. Okay. Everyone understood? Good. Next, we'll be seeing order of magnitude. There's a term called order of magnitude. In science, we represent something in this way. There's a way of writing the answers. A dot B into 10 raised to the power C. This is the proper methodology to write an answer. There are restrictions there. This A dot B should be greater than 0.5 and should be less than 5. Then C will be the order of magnitude. What do I mean to say? For example, you have to write, tell me anything, any answer you say. 49 meters, 5 into 10 to the power 7 centimeters, whatever you say. Tell me something. Ritika, you tell me something. Any value you say.
So what did you actually say? I wasn't able to hear you.
See, this is order of magnitude. Any answer will represent it like this. A dot B into 10 raised to the power C. Where restriction over A dot B is a number, is that it should be greater than 0.5 and less than 5. If this happens, the C will be called the order of magnitude. Okay. For example, I wrote this answer 1.057 into 10 raised to the power minus 16. This is the perfect way to write an answer. Is this value greater than 0.5? Yes or no? Everyone open their mic. I need to hear it from you all. Everyone open your mic. Is this within this range? Greater than 0.5? Yes or no?
Yes, sir.
Yes, sir.
Yes? Okay. Is this less than 5?
Yes, sir. Yes, sir.
Then this is following this order of magnitude rule, and this will be the order minus 16. Got it? If you want to like some answer came 8. Can you tell me what is the order of magnitude of 8? This is the answer 8. Tell me. Okay, I'll tell you. See, 8 is greater than 0.5. Yes or no?
Yes, sir.
Yes. Is 8 less than equal to 5?
No, sir.
No. So we have to represent it like this. Can I write it in form of this? 0.8 into 10 raised to the power 1.
Yes, sir.
Now, is this following this condition? Everyone?
Yes,
Yes.
sir.
So this will be the order of magnitude 1. Understood? Tell me the order of magnitude for 49. Tell me.
So
1. Okay. Chitesh, your answer?
1, sir.
Vandana?
1, sir.
Ritika?
1, sir.
Akhil?
1, sir.
Nice DP. Okay. So, should it be 2?
So
Why
the
cannot I write it like this?
4.9 is less than 5, sir.
Exactly. And 0.49, why cannot I write it like this? Why can't the order be 2? Even this is less than 5. Tell me. Tell me anything. I need to talk to you all.
Sir, like if 4.9 is already less than 5, then why should we round up to the next place?
No, this is not the answer. This is less than 0.5 also. And we have two restrictions. It should be less than 5, greater than 0.5, but 0.49 is less than 0.5. Isn't it? This is the second condition. This is what you have to follow. So 0.49 is less than 5, that's okay. But it should be greater than 0.5 also. That's why we'll stop it here only. Into 10 raised to the power 1, and 1 is the correct answer. Understood? Now good. Okay. Let us move on. Today I think we'll be moving to the dimensions, I guess. We'll be doing it quite fast. See, there are few more topics that I need you yourself to learn from NCERT book. You all have NCERT book for physics now. See, there's a topic called measurement of length by direct methods. Open your NCERT book if you have it by yourself right now. Do you have that nearby? Open that page. After this, measurement of length by direct methods. Opened?
Yes, sir.
Okay. You can see there, they are asking you to calculate the indirect methods for measuring large distances. You can see the topic. Everyone? Indirect methods for measuring large distances. You all have studied trigonometry in class 10th?
Yes, sir.
Yes, sir.
Yes or no? Isn't it the same thing? If you have to measure a distance, let us say we have to measure a height. So AB is the height that you have to measure. What we'll do, we'll set back ourselves a certain distance, let us say X. H we don't know. What we'll do, from this X distance, I'll try to measure this angle to see the top of this point which I have to measure. And then this is theta. So what will I do? Tan theta is equals to H upon X. From there, I'll calculate H is equals to X tan theta. All these things you can do now. Height and distances was a chapter. Should I need, do I need to explain it again? Then they have given a condition like that. Now some object is inaccessible. So what you're doing? You are certain X distance away and you don't know. Okay. Let us say that there is a tower at a certain X distance away and you don't know that. Let us say this is a tower here and there's a jungle in between and you're standing here. You cannot go to the tower to measure the exact distance from the center of the tower and then take the observation like this. So you are at certain distance X that you don't know. And the height of the tower is H. What is there? First, you'll take the reading from this particular distance, the angle of the top of the tower, theta 1. Then you set back a D distance that you know for theta 2. Okay. So what can I write? Can I write cot theta 1 as X upon H, then cot theta 2 as X plus D upon H, right? If you subtract this, cot theta 2 minus cot theta 1, what will that be? This X will get cancelled, right? Everyone?
Yes, sir.
You'll get D upon H. Understanding or not? Right? So if you get D upon H, what do you require? You require H. So H will be what? Take it to the other side. D upon cot theta 2 minus cot theta 1. These are the small things that they have asked you to do it. I don't think that is required there. Even in school, they don't ask. Agree everyone or not?
Yes, sir.
Okay. Then we have this parallaxic method. What we do? Parallaxic method to define another star, nearby star. So what we do? N is there, we take a point. Then we take two opposite distance of that particular star. Like if this is the star, so left hand diameter and right hand diameter we measure, the point we measure. Okay. We measure this angle theta. We know the radial distance D. So can't we measure the diameter of that particular star? We all know that this arc length theta is equals to arc length upon radius, right? Right? Yes or no?
Yes, sir.
Theta is equals to this. Theta is equals to arc length. What is this arc length? This is the arc length upon the radial distance. This is the radial distance. Understood? So arc length will be what? Theta upon r. I shall write it as r. And the here arc length is the diameter. Diameter is theta into r. So all these are present there in your book. You can go through it. You can read it. And then you can let me know if you have any doubt there. Easy things are there like this. Do I need to explain? You just go through the pages. Try to go through the pages, any topic that you want me to explain. All these things are there, trigonometry, basic trigonometry. And we have solved, I guess, advanced trigonometry. We had a different chapter, height and distances. I remember there in class 10th. So you all have done that. Everyone, go through the pages. 3-4 pages are there. And these things only are present. Nothing new. You read these 3-4 pages and come in the next class. Chitesh, any doubt there? Ritika?
Sir.
Any doubt? Anna? Nivedita?
No.
Akhil?
No, sir.
No, sir.
Okay. So these are the distances, measurement of distances. And then you may be having the topic of measurement of mass there. Small topic, 1 page, 2 pages. That will be there. And they generally measure the mass from density. Density is mass by volume. You have to multiply density with volume to get the mass. These are easy things that are there. I don't think I need to teach you. What I need to teach you is start with dimensions of physical quantity. That is something new for you, right? So your homework for today will be, you'll go at home, or you are at home actually. So you'll be studying these 3-4 pages, NCERT line by line, take with a pencil and try to solve these questions, the examples that they have given. No questions will be asked from there, probably. Unless and until the teacher wants to fail you. I don't think you'll be having any grudges with your teacher at school. Do you? Okay. Right. So now we'll be starting the most interesting and important part of this chapter that I personally like is dimensions. Akhil, please switch on your camera. Is there some problem there?
No, sir.
Pardon? Yeah, because I need to see your faces. You are less talkative students. So you cannot explain yourself. You're not able to explain yourself, whether you are understanding or not. From faces, I'll try to read you. Okay. So basically, we had how many fundamental quantities? How many fundamental quantities we had? We had 7 fundamental quantities, right?
Yes, sir.
Okay. So 7 fundamental quantities, and those quantities were represented as dimensions. Okay. We had dimensions of mass, length, time, then Kelvin for temperature, ampere for current. This is ampere. This is Kelvin. This is time. This is length. This is mass. Okay. CD for candela. One more thing, dimensions are represented as square brackets, inside square brackets. CD for candela. And mole for mole. Right? Basically, what are these? For example, if I write what is density? Density.
Mass
so
by
density is
volume.
mass upon volume. Very good. Mass upon volume. What is the unit? So for mass, we write the unit kg. For volume, we write the unit meter cube. The dimensions of density will be for kg. We have kg, it is power 1. So it will be m power 1. Meter cube, length cube, power to the power, it is to the power -3. So this will be the dimensions of density. Nivedita, I cannot see you. Understood? Everyone? Why do we do this? Why do we do this? So dimensions has got its own uses. Okay. Dimensions has got its own uses. We use the dimensions for 3 things. 1, uses of dimensions. Uses of dimensions. 1, for deriving, for deriving formula. Second, for checking consistency of formula. Third, for conversion of units. Okay, so these are the three uses of dimensions. Still, I cannot see you. Is there some problem with the camera?
I don't know, sir. I'll just check it once.
Okay. So these are the three basic uses of dimensions. Now we'll be start first. What we'll be doing, we'll be writing the dimensions of different formulas, and then we'll be moving on to all the three uses, right? So can you tell me the dimensions of area? Area.
Meter square.
That is the unit.
L square, sir.
L square. And you should write the dimensions as m power 0, L2, t to the power 0. These are the basic terms that we use in the dimensions. Okay, we don't use all of these terms, but MLT generally is represented. Velocity. Akhil, tell me for velocity. Akhil. I don't want that nodding head. I want the answer. Unit is meter per second. Now tell me. See from here, convert it from here and tell me the value. That's easy. If it is meter, meter is for what? Akhil?
Length.
Length. What dimensions do we use for length?
So meter.
No, length, dimensions, not the unit.
L.
L. See from here, Akhil. What dimension we will use for second?
T.
T. Are you getting, Akhil?
Yes, sir.
And what is here? Time raised to the power. What power is there for time?
-1.
Are you getting it?
Yes, sir.
It is -1 because it is denominator. So can I write LT to the power -1, everyone?
Yes, sir.
Written, everyone? Understood, Akhil?
Yes, sir.
Good. Chitesh, understood? Next, you will answer. Shall I move to the next page?
Sir.
Shall I move to the next page? Everyone? Right. So next dimension is of acceleration. Chitesh, acceleration.
Yes, sir. LT -2.
LT -2. Very good. What is the unit of acceleration?
Meter per second square.
Meter per second square. So from there you got meter is the power 1 and second is power -2 because it's a denominator. So meter for meter, it is length L, and for second it is length T. Right? Now Ritika will answer. Momentum.
Sir, I have a doubt, sir.
Yeah, go on.
Sir, in the acceleration, they have written as LT power -2, and its formula is meter per second square. So meter has a power of 1. As it 1, so do we have to mention it as 1 or we just leave it?
Generally not required. Generally not required.
Okay, sir.
But
If you're
sir,
writing
if the
just L-
value is 0, then you have to mention it as L power
Yeah.
0.
If the value is 0, you have to mention it here. It should be m to the power 0, LT -2. Okay. The representation should be like this. Okay. But when we write the answers in hurry or in haste, hastily, we forget this. No problem. I don't think teacher will cut marks for this particular matter. Again, unless he or she has no any grudges with you. Depends on you, right? I used to follow my teacher, the way from this classroom to the teacher's room. Okay, right. So momentum, Ritika.
Sir, m power 1, L power 1, and T power minus 1.
Very good. Unit is kg meter per second. Formula is P is equals to mv. You all have studied it. Very good. You are good students. Then who will tell me about force? I can see Nivedita next, but I cannot see her actually. Yeah, tell me the dimensions. Force, Nivedita.
Just a
Are you
second,
there?
sir.
Yeah. Vandana, you think about power or work done. Work done, not power, work done. I'll come to you next.
Sir, is it m power 1, L power 1, T power minus 2?
Correct. What is the unit of force? 1 Newton. 1 Newton corresponds to what? Mass times acceleration. If we go in detail, it is 1 kg and meter per second square. So for 1 kg, it is 1 mass, m to the power 1, meter to the power 1, that is length to the power 1, t to the power minus 2 from here. Very good. Work, Vandana.
Sir, it is force into displacement. M1, L2.
Then?
T to the power minus 2.
That's correct. It's force into displacement. Force you have understood from here. This you just have to multiply with the length, and you added 1 length here. You got L to the power 2. Everyone understanding or not?
Yes, sir.
Akhil will tell me about pressure. Pressure. What are the dimensions of pressure? First, tell me what is the unit. Formula. Formula of pressure. What is pressure? Define it. Parents are putting lots of pressure on you, right? Pressure is force per unit area, na?
Yes, sir.
We studied in class 9th. Pressure is force per unit area. Now tell me, what is the dimension of force? Dimensions of force from here.
So m power 1 and L power minus 3.
How it's minus 3? Okay, you are telling the whole answer. Minus 3. Okay, then?
And so T power 1.
T power 1. How can it be? This is wrong. Force, you can see it from here. What is force? M,
Sir,
L, T
m
to the power
power
minus
1, L power minus 1, and T to the power minus 2.
2. Exactly. Exactly. So force, you can see it from here. ML, T minus 2. Okay. And then you have to divide it by L square. So when you take L square and then power 1 is there, if you solve it or simplify it, you'll get minus 1. Understood, Akhil? Okay.
Yes, sir.
Now there are many of them. The whole formula of class 11th and 12th has been described in your book, NCERT, when it is written in a big tabular form, and you don't have to study it. Yeah, some of them you have to study it basically for stress, strain. Okay. Then we have coefficient of viscosity. They ask this question. Favorite question of every teacher. Coefficient of viscosity. Nobody has learned this, but still they'll ask. This we have to study in fluid mechanics in the second part of the same year, same book, NCERT class 11. But still they ask the question. Coefficient of viscosity eta. The formula says that force is equals to 6 pi eta RV. Okay, R is the radius. V is the velocity, terminal velocity. What happens when you drop any ball? You feel the drag force now. When any ball is dropped, any object is dropped of the radius R, there is a drag force upwards because the ball is getting dropped downwards in the liquid. You feel the drag force upwards, and that drag force is equals to this 6 pi eta RV. Eta is the coefficient of viscosity. Viscosity is what? What is viscosity? Viscosity is that property of fluid with which we get the friction in liquids. Right? Little bit about it we have studied in class 9 fluids. Remember everyone? So from there we can find the dimensions of it. How we can find the dimensions of it? I'll tell you how. See, what is force? So force is nothing but mLT to the power minus 2. Agree everyone? Switch on your mics. I need yes sir in every term.
Yes, sir.
Yes or no?
Yes, sir.
Right? So force, now I have to equate it with the right hand side. One more thing, the constants have got no dimensions. For 6 and pi, we cannot write anything as dimensions. So we should exclude them from dimensions. Okay, we should exclude them from dimensions. So constants have got no dimensions. You have studied differentiation integration in physics,
Yes, sir.
right? So in differentiation and integration, what do? We take out the constants from there, na?
Yes, sir.
Yes or no? So we take out the constants from there, right? So similarly here also we have no dimensions for constants. That is a drawback of constant dimensions, because we cannot write the constant dimensions of constants. So what we'll be writing? We'll be writing eta, that we don't know. Eta, what is the dimension of eta, that we don't know. Okay. Then we'll be writing of dimensions of radius, that is L to the power 1, and dimensions of viscous velocity, that is LT to the power minus 1 and whole to the power 1. Because radiation is also power 1 and velocity is also power 1. Now what you have to do? We have to equate with eta. Eta dimensions will be what? Its dimensions will be what? M L T to the power minus 2 divided by L to the power 1, and again L is there, and again T to the power minus 1 is there. Agree or not?
Yes, sir.
So can I solve it like power M for power is 1 for M? Then it is, or I shall directly write it like this. I just wrote it like this to explain it to you. So L to the power 1 and niche, the denominator is minus 2, and then T to the power minus 2, and from denominator minus 1 goes up to plus 1. Agree or not?
Yes, sir.
Everyone?
Yes,
Yes,
sir.
Understood? Any doubt? If you not understand this, you won't be solving the other parts of dimensions. You get this as dimensions of eta, ml minus 1, t minus 1. Got it or not?
Yes, sir.
Everyone, Ritika understood?
Yes, sir.
Chitesh,
Yes, sir.
Akhil,
Yes, sir.
Nivedita,
Yes.
Vandana.
Yes, sir.
Good. So this is one part of dimensions that you do, right? Write it down. Written, everyone?
Yes, sir.
Is this interesting?
Yes, sir.
Chitesh is like, should I consider it yes or no?
Yes, sir.
Yes,
Sir. Heart is saying no, mind is saying yes. Right? Okay. Shall we move on? Right. So we'll be studying today the first one part of it, that is conversion of units. Conversion of units. So we'll be getting back to that N1 U1 is equals to N2 U2. You all remember the last class we did? Everyone?
Yes.
Right. So N1 represents what? The numerical value in the system of units 1. N2 represents what? The numerical value in the system of units 2. For example, we have, I'll take one example. We have force, or I'll just take another example. I'll ask you as this question. We have in SI unit, we measure distance as meter. In CGS unit, we measure distance at centimeter, right? So dimensions will be M0, L1, T0. Here dimensions will be M0, L1, T0. In any system of units, any particular quantity has the same dimensions. Got it? If I write in FPS, we measure it by foot, same dimensions, because that is a kind of length only, na? Any system of units, the dimensions are same. Got it? Now see here, I have to convert 5 meters into how many centimeters? I don't know.
500.
I forgot it. What I know is the knowledge of dimensions. I'll use it. So in N1 system of unit, my value is 5, and the U1, I'll write U1 in dimensions. U1 is M0, L1, T0, right? Okay. I'll write M1, L1, and T1. Why? I'll tell you later. In second system of units, I don't know the exact numerical value, but I know the dimensions. Dimensions are still same. That is M2 power 0, L2 to the power 1, T2 to the power 0. Agree with me or yes or no?
Yes, sir.
Everyone?
Yes, sir.
Said everyone. I don't know whether you are knowing this or not. Chitesh?
Sir.
Akhil?
Yes, sir.
Nivedita?
yes, sir.
Okay. Now see here, I want to know this value of x. So x will be what? 5 times M1 upon M2 to the power 0. Then L1 upon L2 to the power 1. And then T1 upon T2 to the power 0. Right? Now tell me, M1, L1, T1 was in the unit of SI. And here we had CGS. What I have to do, I have to relate this. This is power 0. So all of this will become 1. All of this will become 1. What I am left with is L1 by L2. I have to find the relation between L1 and L2. L1 is in SI unit. So that is 1 meter. Right? L2 is in CGS unit. So that is 1 centimeter. So how can I relate 1 meter and 1 centimeter? Can I write it as 100 centimeters? And here in L2 in CGS, it is already 1 centimeter. Can I write it like this? Power 1. Everyone?
Yes, sir.
Got it?
Yes,
So the centimeter gets cancelled. What I'm left with is 5 into 100 to the power 1. That gives me 500 centimeter. That is my answer. Yes or no?
Yes, sir.
Got it? Write it down. Or before that, let me explain you one more question. This was one easy one. I'll tell you one more question. I have to convert force. That is the SI unit 5 Newton. I have to convert it into like dash dyne. Dyne is in CGS unit. Like in Newton, we had 1 kg meter per second square. Now in CGS, we had 1 gram centimeter per second square. Okay. And this collection is called Newton. This collection is called dyne. I have to find this relation. Okay. I have to find this relation. How will I find? So what will I do? I'll take the dimensions. N1, that is 5. Dimensions of force. Nivedita will tell me. What are the dimensions of force? What is the dimension of force? Are you there?
Sir, m power 1,
Hmm?
L power 1,
Hmm?
and T power minus 2.
Minus 2. I'll write M1, L1, and T1 for first system of units. Then the second numerical value, I don't know. Dimensions will be same. M2 power 1, L2 power 1, T2 to the power minus 2. Agree, everyone? What I
Yes,
need to
sir.
find is X. X is 5. Then M1 by M2 to the power 1. Then L1 by L2 to the power 1. And then T1 by T2 to the power minus 2. So first system of unit was in SI. In SI, what is the unit of mass? Vandana? In SI, what is the unit of mass?
kg.
And in M2 system of units, it is? That was CGS. We considered as CGS now. So it is gram.
Gram, yes, sir.
So 1 kg upon 1 gram power 1. Here, Akhil will tell me what is the length, unit of length in SI system of unit?
So meter.
Meter. And CGS, it is centimeter. 1 meter, 1 centimeter power 1. Now, Ritika, time in both the system of unit is?
Seconds.
Seconds. So 1 second, 1 second, power minus 2. So this gets cancelled. Everything is 1 here. Right? 1 meter and 1 centimeter. Can I write it as 100 centimeter upon 1 centimeter? And the third thing, can I write it as 1000 gram upon 1 gram? So that I can cancel the units and into 5. So how much do I get? 5 into 10 to the power 3 into 10 to the power 2 into 10 to the power 5 dynes. That is 5 newtons equals to 5 into 10 to the power 5 dynes. Did you get this or not? Yes or no? Everyone?
Yes, sir.
Yes, sir.
Ritika?
Yes, sir.
Hitesh got it. Akhil, understood?
Yes, sir.
Good. Now write it down and I'll give you questions. This was one of the most important things. You can get this as question in even in JE or in school. School, it is mandatory. They'll be asking you this. So understood it. Now, any doubt anywhere, even if small doubt is there, get it clarified. This is your tuitions. If you'll not ask me, whom will you ask? School teacher will get angry if you ask the second time or third time, I guess. Even sometimes he gets angry in the first time itself. Isn't it? You sit down. I won't answer you. You ask police questions. Any doubt anywhere, any clarifications you require. I don't care whether that question be foolish or not.
No, sir.
That's good.
Done, sir.
Done? Okay. So
Yes, sir.
we'll end it here today for physics, right? And after 5 minutes, exactly after 5 minutes, it's 11:02. At 11:07, we'll be joining for maths, right? Understood the session? Any doubt anywhere? And did you like the session? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.